All right, here's a problem of the day. It's x to the fourth minus 256, and we have to factor that. And this would be one of those things where you would see the words factor completely. So hopefully you can see this is the difference between perfect squares. Again, we talk about it this way, the difference, okay, and it's between two perfect squares. So when we actually factor this, we know when we have the difference between perfect squares, it's going to be the square root of the first term. So it's going to be the square root of this. And we should be able to figure out the square root of x to the fourth is x squared. So in the first parenthesis, this is going to be an x squared here. And it's going to be an x squared here in the second parenthesis. And then finding the square root of 256. And again, most of you will know that's 16. And then we place our signs. And again, it's the difference between perfect squares. So you know this is going to be a plus and this is going to be a minus. And again, the order doesn't really matter, just as long as you have them right. One's positive and one's negative. Okay, now we look at this, and when we look at this part, we can see this is not the difference between perfect squares. This is the sum of perfect squares. The sum of perfect squares can't be factored. So that one is done. But if we do look back and we look at the second one, now we look at this one, again, we have the difference between perfect squares. So we have to factor just that set of parentheses. So the first set is going to stay this way. Now the second set is going to factor just like it was its own problem, just like the entire problem was factor x squared minus 16. So again, the square root of x squared is going to be x, so we get an x and an x. The square root of 16 is going to be 4. And then again, one gets a plus, one gets a minus. This is now factored completely.